I know it's a little early, so I'm just going to tell you a bunch of jokes. Because, like, that's what we do, right? So usually this joke goes like, why did the JavaScript developer quit? But I guess it's Java developer here. So why did the Java developer quit? Because he didn't get a raise. Come on, I got 3 kids. I'm a dad. This is dad joke time. Anybody dads over here? Moms? Parents? Yeah. When is a joke a dad joke? When the punchline is apparent. Yeah. So yeah, when I don't do JavaScript, I guess I do this. How many people have heard about Qwik? All right. Oh, wow. Okay, good. I hope good things. So this is like the faction of Java developers who are like trying to escape to JavaScript. Is that what this is? Let's see. How do functions break up? Wait, sorry. This is Java conference. How do methods break up? They stop calling each other. How do methods have arguments? Oh, sorry, I messed it up. How do methods fight? They have arguments. No, you guys don't know any jokes? I need to like add to my repertoire. You know where I keep my dad jokes? In a database. Imagine working with me. I'll let my wife know. Yeah, I'm not quite sure who got the better end of the deal. So why, since most of you guys already heard about Qwik, what is bringing you here? To find out more, or are you trying to use it? Who actually coded something in Qwik? Wow, 1 person. Way to go. Oh, by the way, I have swag and I have t-shirts. See me afterwards. I need to gain your liking through stuff, That's how it works. I give you random things and I'll be hanging out after the talk in front of the theater, I guess, right in front of the door, and I will have swag to give out. Oh, are we good to go? Are we going? No, not yet? Okay. I'm getting excited here. More jokes? Really? What happened to the program that ran away? It got executed. How long did a function... Oh, wait, no, that's not how it goes. Oh, yeah, how long did the function run for? For a while. I have a sticker on my computer that says, bang false, like exclamation point false, and it says, it's funny because it's true. What? Oh, we were live. Okay, let's talk about Qwik. All right. So hi everybody. I am Misko. I am the CTO at Builder.io, where we're building a visual CMS system. But I'm working on this new thing called Qwik, and I'll tell you a little bit about it later as to why Builder is working on Qwik. Hey, but you might know me from before. I did this thing called AngularJS, Angular, Zone.js. Before that, I did this thing called Clean Code Talks, where we talked about testability, and I had something to do with Karma. So that's a little bit about me. So what we're going to talk about today is that JavaScript is the big problem. It is the problem that we want to solve. And it's not your fault in the sense that like a lot of people like to blame the developer for the huge amount of JavaScript that we're creating. I'm saying it's not your fault. And there is a solution. So let's talk about it. So the thing we want is to get amazing performance. So one thing that the world has noticed is that the faster your application starts up, the better the experience for the user, the more users show up. Google knows this so intimately that they have made this tool called Google PageSpeed. And you can go and submit your application to Google PageSpeed, and we'll give you a score. Basically, the score has to do with like, what's the quality, like how long does it take to make the application interactive? And it turns out that most of the apps are kind of in a bad state. But before we get there, this went black, so did something break? What happened? Yes. Okay, good. Okay, so what is the problem? The problem is that slow apps cost a lot of money. And money, mainly this comes to e-commerce, but e-commerce is not the only place that this is a problem. And both Google and kind of the world of compiled this information that basically said, look, the slower your site, the worse the conversion ratios are, right? The slower your site, the fewer people sign up. The slower your site, the less money you make. And this kind of makes sense, right? Like you're on Twitter browsing, you see some ad for a shoe, you click on it, you come to a website, and you're like, oh, okay, cool shoe, I want to buy it. You click the buy button, and it's not working because it's not downloaded yet. And so you say, you know what, I don't really need that shoe, and you leave, right? Whereas if the app was quick to start, you wouldn't have that problem. And so the reason for that is, well, look at the amount of JavaScript we're producing. This is JavaScript, average amount of JavaScript on a page over time. And what you can see is that it just keeps going up, and up. And the reason for that is, well, we're getting better at producing more interactive sites. Like the sites of today versus the sites of 10 years ago are very, very different. And so the problem we're having is that in order to make a nice interactive site that the users want to use, we have to produce a huge amount of JavaScript. But in order to have a site that actually starts up quickly, we have to have as little JavaScript as possible, right? And so this is the kind of the paradigm that we're in. And if you don't believe me that JavaScript is the problem, we made this tool called Performance Insights. It's a very simple tool. What it is, you take a website and you put it in, and in this particular case, it comes back as 36. 36 is a kind of a normal number for most of the websites out there. And so then we try to optimize the images. And in this particular case, we get a performance boost. We try to optimize the CSS and we get a performance boost. What it means is that this particular company could have done better optimizing those things. But here's the interesting bit. The moment you optimize JavaScript, and when I say optimize, what I really mean just delete. Okay? The moment you delete the JavaScript, the site is immediately 100 out of 100. It just becomes fast because JavaScript is the problem, right? Basically what's happening, we're producing so much JavaScript, we're throwing it on the main thread, and we're overloading the main thread so that the main thread is busy, especially on a mobile device, for the next 10 to 20 seconds before anything can happen. And so if you look at top 50 e-commerce websites, obviously this font is too small to read, notice that just about nobody is in, well, first of all, nobody's in the green, very few people are in the yellow, and okay. Very few people are in the yellow. So what we have here is, for example, Amazon is doing a good job, Staples, surprisingly, and IKEA and some other company that I can't read over here. But most of these companies are actually in the red. In other words, they're e-commerce websites. They understand the importance of being fast, and yet they can't get there. Right? So the typical thing that happens is that we blame the developer. Like, oh, these companies just don't have good developers and they just create a crappy product. I'm like, really? Like, even in top 50 websites that clearly have the money and clearly understand the importance of this, we still have this problem. And actually, Amazon is a perfect example because they actually score rather well. They spent huge amounts of time and effort at making sure that their website is fast. And so they're actually a pretty good thing, but still they don't get a perfect score. And so the thing to notice here is that if we could somehow fix the JavaScript problem, right? If I just delete the JavaScript, which is this column right here, if I just delete the JavaScript, just about every website can get yellow or better. And if you fix the JavaScript and images and CSS, just about every website can go to be green, right? But that's the problem. How do we fix the JavaScript? So let's talk about JavaScript for a second. The problem is that you have different frameworks, and you can see that different frameworks have different slopes. What this means is that there is some initial cost to a framework, which is shown over here, right? Which is the interception with the 0, and some slope. Basically, for every single character of HTML that you add to your application, what is the equivalent amount that comes out of the framework on the other side? And different frameworks have different slopes because, well, they have different technologies of dealing with this particular problem. But the thing to notice here is that they're all basically O of 1, meaning that they're all linearly increasing. The more complicated your application becomes, the more JavaScript you're producing, right? And this is the problem. This is what we need to fix. Now, Qwik is the framework I'm going to talk to you in a second about now, is different because it is O of 0. O of n is the previous frameworks. Qwik is O of 1, meaning it doesn't matter how humongous your application becomes, the startup performance is always the same. And this blue line here is supposed to be around 1 kilobyte. So with 1 kilobyte, you can get any application that you want up and running and become fully interactive without anything. Sounds crazy, doesn't it? So let's kind of dive into it a little more. My point here is this trend is continuing. It's not going to stop. And so we need to do something. We need to basically create a different set of frameworks that can break this trend, that can basically say, look, we understand that as developers, we need more and more JavaScript, and there's going to be continuous need for it to have more interactive websites. But we need to do something about the system because as it stands right now, the problem's just getting worse. And it's not like the CPUs are getting faster. They are getting faster in the sense that they're more parallel, but JavaScript is single-threaded, so that doesn't help. The individual cores kind of have reached the limit of how fast they can run. Now, if you look at a history of how we got here, in the past, we built websites using something like PHP or Rails on the back end, or Java. And in the front end, we had JavaScript, jQuery. And these websites actually were very performant. And this is today how Amazon works. And this is why Amazon still has pretty good numbers. They're performant in the sense that the server can generate huge amounts of HTML very quickly. Browsers are excellent at turning HTML into something that's visual. And jQuery is kind of a progressive enhancement. You just kind of add a little bit of sprinkle of jQuery and certain buttons become interactive and then kind of the whole world kind of works. The problem with this particular thing is that nobody wants to write code this way because you have to write the code twice. Once in a backend language like PHP, Rails, Java, and then again in JavaScript because if the backend server renders your let's say your address, and then the address is editable in a jQuery, you basically have implemented the same thing twice, once on a server and once in the client. And so for this reason, there's been a general trend to move to frameworks such as Angular, Vue, Svelte, React. Pick whichever framework is your favorite, and it kind of falls into the current category. Now, the thing that's really good about this approach is that it's a unified mental model, right? The same code runs on a server as runs on a client. I really only have to have one thing and everything works, except there is a problem, and that is the hydration, right? The user sees nothing until the JavaScript executes. And so we have a workaround for this, and it's called server-side rendering. So we server-side pre-render the application. The user looks at the app and thinks to himself, oh, great, I have an app that I can interact. No, it's a lie. It's really just a picture of an app. You can't really do anything until the JavaScript downloads all your application and then executes it, right? And this is where the slowness comes in, because it's super, super slow. So I'm predicting that in the future, the thing we want is super fast performance, right? We want our unified mental model of just writing JavaScript and be done with it. But we want to have O of 1 frameworks. And it turns out Google has had this thing for the past 8 or 10 years. And it's called Google Viz. And if you go to Google Search or you go to use Google Photos, one thing you'll notice is those apps are amazingly snappy. The moment you see the content, you immediately can go and interact with it. Now, it turns out eBay is working on something called Marco, and new version of Marco version 6 is also supposed to be resumable, and I'll define the thing in a second. And of course, Qwik, which is the framework I want to talk to you today, is resumable from day one. Okay, so what is Qwik? So Qwik has two magical properties, and I'm going to get into it in a second. One is that it's resumable, and I'll define what that means in a second. The second is it's progressive. So let's talk about resumability first. First of all, I'm going to show you a demo of what this looks like. The two pages are identical. These are our home pages. The page on the right is running on Qwik. Notice how HTML shows up and it goes gray, meaning there is no JavaScript executing. It's finished, it's done, it's ready for interaction. The page on the left just happens to be inside of React and Next.js, but the same outcome happens in any framework you choose. Notice how long it stays in color. That is what's happening while it's in color is it's downloading the JavaScript, it is executing, it's reconciling, it's figuring out where to put the listeners, and finally places the listeners in a DOM, and then it can go gray. And at that point, when it goes gray, is when you can click on the menu button. And if you look at the performance, it's like 4 times the time performance. So what is resumability? So I like to talk about resumability from the point of view of virtual machines. So in the virtual machine, you have your host machine, and let's say you boot up Linux inside of your host machine. And Linux, boots up, it prompts you with a login screen, so you type in your username and password, you log in, and let's say you open up a spreadsheet and you start working on some document, and you work away, and at some point you're like, you know what, I'm kind of finished. And so you save the virtual machine. And a virtual machine gets saved into a file. And the thing that's interesting about this file is that you can take it to a different physical machine. You can send it to your friend. And your friend can open that file on their machine, and they're exactly where they're left off, right? They don't go through the boot up process, login, and opening up a spreadsheet. They're literally just opened up, and they're exactly where you left off, and they can go and interact. And because of that, their equivalent of boot up time or time to interactivity is greatly reduced because they're skipping over the hardest thing, the boot up process. And if you think about it, hydration is exactly that. Hydration is the boot up process. So what we're talking about here is a way of running the application at the server, serializing its state into HTML, sending the HTML over to the client, and on the client, you're just ready to go. You're basically, there's no more stuff to do because you don't have to go through the equivalent of a boot up process in there. So let me show you why I call it resumable and replayable. So on a server, we have to execute the application, right? And then, of course, the application has to get serialized. At this point, the result of the serialization can be placed in a CDN so that you don't have to pay for that in the future. And then when it goes to the client has to, download the application. The whole application has to get re-downloaded. The whole application has to get re-executed because the framework needs to figure out where are the component boundaries, where are the listeners, what is the DOM structure, and so on. And then you have to reconcile that information. The framework has to reconcile that information against what's actually in a DOM in order to figure out where to put the listeners. And only then can you go and interact with the page. A resumable framework does the same exact thing. On a server, you have to do the same thing. You serialize it in this point over here. You can save the result in a CDN if you want. And when you come to the client, it's just like, you just have the page already ready to go. You have the state that was already serialized as part of it, and you can just continue. You can just resume where you left off without any JavaScript. And that's kind of the magical bit. Okay, so the second thing is that Qwik is progressive. So in a normal framework, when you navigate to a page, you really have to download all of the JavaScript associated with that page, right? If a component is somewhere in a DOM, whether it's on the top or on the bottom, it doesn't matter where, if it's on the page, you have to download the code associated with that component because the framework doesn't know if there's listeners or not. And the only way for the framework to figure out where the listeners are is to go and visit every single component and look for the listeners. And when it visits every single component, only then can it attach it. So the way normal frameworks work is that they download all of the code up front, and you have to wait for it. Then they have to execute all the code up front, and then you can go and have interactivity. What's different about Qwik or resumable frameworks is that they start with very little JavaScript. In the case of a Qwik, we're talking about 1 kilobyte. And then as you interact, every time you interact, more JavaScript shows up. But only the JavaScript necessary for that interaction, not for the whole thing. Which means the amount of JavaScript in the browser is proportional to the kind of interactivity that the user is doing rather than to the overall complexity of the application that you have. Okay, so we kind of mentioned that there are basically these 2 categories of frameworks. There's the replayable frameworks, as I mentioned on the left, and there's resumable frameworks, out of which Qwik is the one that we're working on, and we're trying hard to kind of popularize the resumability aspects of it. Now, the thing that people get hung up on all the time is they focus on these benchmarks. I'm sure you have seen these benchmarks, right? They all claim how every framework is the fastest, best, whatever. I actually am going to say that these benchmarks don't really matter actually that much. And the reason why they don't matter is couple. First of all, they all assume that JavaScript is already downloaded. Not the case for initial interaction. They also assume that the jitter has already done its magic and it's warmed up. Not the case for first interaction. They assume that the problem is updating the DOM, which I'm going to say, again, is not the problem, because when you navigate to a page, the problem isn't updating the DOM. And even if you add an item to the shopping cart, you're adding one extra line item into the shopping cart. So the test that tests how long does it take to insert 1,000 rows is not really relevant. And finally, these tests completely ignore time to interactive and total blocking time. And so I think we're focusing on the wrong thing. And instead, I really would like to change the discussion and focus on startup performance. And so here is a to-do application built we have this technology called mitosis that allows us to generate different outputs for different frameworks. Anyways, so here we built the same exact to-do application in different frameworks. And what you see is that there's a huge discrepancy in terms of startup performance from obviously Qwik, which really focuses on a startup performance, all the way to Angular, Next, and Next. And as you go to the right, things just get slower and take longer and longer to both start up, but also the amount of JavaScript that's actually downloaded in order to make the page interactive it goes up. So Qwik is in beta. Let me do some demos, right? Everybody wants to see demos. All right, demo time. So let's come to a simple page, which all it has is an alert, which shows up an alert, and it has a increment button. And I need to make the font bigger. How's that? Okay, so let's go to Network tab. And this is running in dev mode. And because it's running in dev mode, it's running in Vite. And Vite is the thing that does hot module reloading. Vite doesn't gets compiled away in production. So I'm going to just filter out Vite for a second, right? So just pretend Vite's not here, because in production it wouldn't be there. So the thing I want to show you when I navigate to this page is there is no JavaScript whatsoever. Like, there's nothing in here. And when I click on the alert button, the alert shows up, right? And the only thing that we downloaded is the code necessary for the alert. Nothing else got downloaded, just the code that's absolutely necessary. So let me refresh this page again, and let's hit the increment button and notice the same exact thing. I clicked the button, and what I downloaded is the code necessary for the incrementing. And then in this particular case, the framework had to download because we actually have to update the UI. Notice the interesting part is that when I clicked on the alert, the framework didn't download. The system was smart enough to kind of realize, actually, I don't even need a framework to be downloaded in this particular case, and really just downloaded the interaction by itself. And so you might say, like, well, how does this magic work? So let's have a look. So let's look at the alert button. And what you're going to see is that when I say serialize the state, we are able to serialize everything, including listeners. So in this particular case, we know that this button has this listener. And this is the URL. It gets shortened in production. In developer mode, it's kind of nice and long. And it basically says if you click alert, this onclick should execute. And there is a piece of code at the very, very bottom, which is called the quick loader. This is that 1 kilobyte. It is so small that we actually inline it into the initial download. And this piece of code basically knows how to kind of download the rest of the system as necessary. The other thing to kind of point out is, what is the developer experience? Where is my, oh, I see, it went over here. Oh no, that's not what I wanted. That's never what I want. Let's fix this. Sorry, I know how to use a computer, I promise. Let's do this again. Okay. And this is the wrong window. Okay, this is the right window. Okay, so counter. Let's talk about counter. So what's cool about it, that as a developer, you don't have to think about it. So for those of you who know React, you're going to look at this and be like, this looks just like React. And so in this particular case, what do we have? We have a counter. We declare a store. This is where we store the count. We have other components that we can refer to. In this case, we have the 2 buttons. One button says click increment, and it says, store.count++. The other button just says console log and alerts, right? So you write code in a normal way. You don't have to think about, like, should I lazy load? Should I not? How do I do that? None of that stuff really matters for you. And you have a child component over here that knows how to render the count and update the UI, right? So you write the component in kind of a normal way that you're used to. The magic comes in that Qwik has these dollar signs everywhere. See this dollar sign here, and here? Every time you see a dollar sign, special rules apply, but basically you have to think to yourself, oh, by the way, should I make the font bigger? The thing you should think about yourself is like, oh, lazy loading happens here. This is a component boundary. In other words, this code here, this on-click code, can be downloaded independently from any other code. Same thing over here. This on-click code can be downloaded independently from any other code. Now, the thing that's interesting is that we need to capture the store, right? There's the store over here. So this code that's over here somehow is a closure that needs to be serialized in such a way that we can recover the closure without re-executing the component. And that's kind of the part of the magic of Qwik. So when I go and click on where is the network tab? Here it is. When I click increment, right? Let me refresh this again. Click increment. The only code that downloads is really this click and store count plus, right? So that's this code right here. Nothing else downloaded. And we insert a special magic in here that actually restores the scope, right? The store that the function is capturing, so that we can essentially serialize the closure. Now, obviously, this requires that we download the framework itself. So that comes over here. But notice that nothing else showed up. Like, not even the template, right? This piece of component that goes and updates the current number, even that code didn't download, right? The framework is able to really reason about the system and say, what is the bare absolute minimum that I have to download and execute in order to achieve what the developer has coded up here without developer really having to think about it. And so the amount of code that downloads is really remarkably little. Now, the thing to point out is that every time you see one of these funny-looking comments, that's actually a different component. So this page probably has about 20 different components, right? One for the header, one for the footer, and other pieces around. And yet, the system says, you know what? Most of these components are irrelevant. They never download. Why bother sending them to the client? And it doesn't get sent to the client. OK. So let's talk about another demo, which is kind of my favorite demo over here. And it's a very simple demo. All it is there's a clock that updates every 1 second at the bottom of the page. Now let's scroll to the top, come here, network tab. Again, no JavaScript. How is this possible? And notice what happens. When I scroll the clock into the view, the JavaScript shows up right in time as the component is becoming visible. So first of all, I want you to think about like, well, how would I even code that up? Like in your existing framework, how would you do that? How would you delay something until it becomes visible? And you realize it's actually quite difficult. I'm going to actually go on a limb and say it's pretty much impossible. But let's see what we had to do inside of Qwik. So first we have our basic component, and here we have a set of items. And really the only code here is so that the set of items gets generated, right? The whole purpose of that component is to just generate this list of items. So this component just generates a list of items so that the clock itself is below the fold. Then we refer to the clock, which is right here. The clock component says, I need this style. There is a state, right? There's my store. I need the angle of the hour, minute, and second. And I have a use client effect. And use client effect is a way of saying, like, I need to execute something in the browser, right? And in this particular case, what we're saying is, well, you need to update the angles every 1 second, right? So this set interval is what we need to execute. And so this piece of code basically wakes up and goes and executes every 1 second. And finally, we have a template that kind of draws our clock. This is what the clock's supposed to look like. Now, in the normal systems, in normal frameworks, whatever the equivalent of the use effect is, the question is, when should you execute this particular function? And so in normal systems, the answer is kind of obvious. Well, you execute it during hydration, right? But there is no hydration in Qwik. So when exactly should you execute this function? And so the default behavior of this function is to be executed when it becomes visible. You can change the default by passing additional arguments to the function, but the default is just when it becomes visible, do this particular work. And so without even thinking, without even trying just doing the normal thing you would do in any other framework, you get this interesting behavior out of the system that no code is present, and then when the clock shows up, it goes and starts executing the stuff. Now, notice that the only code that's downloaded was this update function. Can I make this bigger? No, maybe not. This is just this closure right here, right? This is the closure that's being downloaded here, and it's executing every 1 second. And of course, the framework itself has to be downloaded. Notice that not even the template associated with the clock is being downloaded. And that's kind of mind-blowing if you ask me, right? Like, the system, without any sort of effort on a part of the developer, the system is really figuring out, like, what is the absolute bare minimum amount of code I can send to the client to achieve what the developer wants without developer having to think about this. Okay, let's do a next demo. Okay, let me do a to-do demo, and I think I have it. Okay, here we go. So every app needs to have a to-do, right? It's a rite of passage for a framework. So let's go again to the network tab. And I want to show you this idea of progressivity. So I showed you this idea of lazy loading, right? That you only download the absolute bare necessity that you have to download in order to get the page going. So now let's talk about the progressive nature of it. So again, look at the network tab and notice that the network tab is empty. There's nothing in the network. And as I start interacting with the application, every time I interact, notice more JavaScript downloads, because hitting enter and inserting a new item required more code. Now, checking an item requires even more code. Deleting an item, more code shows up. Clearing an item, every time you interact with the page, more and more code is downloaded to the client. Because again, the Qwik has this philosophy is like, don't download anything unless you absolutely need it at that moment. And so what you get to is it doesn't matter how big the application becomes, right? You can have the largest app in the world. All it matters is how complicated are the operations that the user is actually performing, right? If this to-do app would be part of a larger system, we're not downloading the larger system. We're only downloading the individual pieces. Now, I'm going to show you one more cool trick. It's kind of similar to the idea of resumability, right? The idea of moving application basically from one virtual machine to another virtual machine. So I'm going to add a new item here. And let's say I'm going to hide a couple of items, and so I'm going to say only show me the active items, right? So there are a couple items that are hidden. Now, in most systems, let's go over here, and I am going to pause the application, right? This is equivalent of shutting down the VM. When I pause the application, the system basically serializes all the data it has and inserts the data into the HTML. So then I can go and I can copy the HTML associated with it. Let's go to a different tab. This tab, let's just delete what's in here. Where is this? Edit. Why don't I see it? Oh, here it is. Okay, so we're deleted, right? It's a blank tab. Let's go in here again. And this time, I'm going to paste the HTML from the other tab. Now, the fact that the application shows up, that's unremarkable, right? That's just HTML. But the question is, will this application interact, and will it remember its previous state, right? If I click all, will I see what was there before? And I do. And this is kind of, if you know how regular frameworks work, you should be going like, what just happened? This is not supposed to happen. This is not how apps work. But Qwik has this property that it can be serialized at any point and moved to a different location. And this is exactly how Qwik gets from the server to the client. This is the trick we're doing in order to get from the SSR to the browser in a way that is efficient, and we can continue execution where we left off. And oh, by the way, I should have showed you the network tab. The network tab was empty, and as you started to interact with this particular page, more code downloads, right? So now if I do clear, even more code downloads. So again, by moving the application over, all the data is deleted, and we kind of move it over. Let's see, where are we? Okay, I know what you're thinking. At this point, everybody says, yeah, that's pretty cool, but what happens if you're on a slow network? Right? Wouldn't you like have a waterfall, and also, you would have to wait, like the first interaction would be super slow. So let's talk about that. So here is our homepage, And I'm going to have to make it a little smaller. OK, here we have a search button. OK, and let me refresh this again. OK, so we come to our home page. No JavaScript, right? Nothing in here. I can even take. Oh, sorry. This is still running in developer mode. So this is in developer mode. There's no JavaScript. Vite doesn't count because it's developer mode. And now I'm going to go and click on the search button. And notice what happens. Huge amounts of JavaScript have to get downloaded, right? And this is a problem, right? Especially on a mobile device, especially on a slow device. And you don't want this. So what are we doing to address this particular problem? So first, let's flip over to the same exact build, and I hope I have it right. Let's see. Make sure I'm showing you the right demo. Why are you not hiding? Here we go. Config. Sorry, let me save this. Okay, and I'm going to rebuild the system and rebuild it. So the way Qwik deals with it is that we have a service worker on a separate thread. And a job of the service worker is to figure out what are the possible things you could possibly do as a user and start prefetching code ahead of time. So let me refresh this page again. So this time we are in production, so there is no filter in the network tab, and you can see no JavaScript showed up. Now I'm going to click on a button, and again, I have a long list of things that waterfall down, but you can't see it over here, but this parentheses over here, if you see, this is service worker, and of course, it's not going to show you. The font is super tiny, but basically, all of the responses came from the server immediately. I should even be able to do throttling and refresh and show you that it's instant. It's instant because the service worker is running in a separate thread. Let me turn off the throttling. It's running in a separate thread, and it had prefetched all that stuff. So if I go to the application right here, you look at the cache, the service worker was ahead of the user, and the service worker looked around and said, you know what, as a user, I can see that you can click here, here, and there, and I have a full graph of all the related chunks, and therefore I know what to download. And at this point, you might say, like, well, isn't that the same thing as if you just download the whole application? And the answer is no, for two reasons. First of all, none of this code has to get executed on the main thread, right? All of this code just prefetches in the service worker. The second reason why it's not the same thing is that the amount of code that's downloading here is actually a small fraction of the overall application. Overall application includes everything that you see on a page. This is overall application. But really, if you look at it, the only thing you can do is interact with the search button, right? That's the only thing you can do. Or if you are in this mode, there is a menu that you can interact with over here. There is no other interaction that you can do on this particular page. So the amount of code that the service worker has to download is way, way smaller. But we still have the waterfall problem, right? We still have the fact that the interaction cost tons of JavaScript to download. And so what can we do about that? Well, what you can do is you can observe actually how the user uses your application and collect what we call symbol information. So each one of these files contains a symbol, contains one item that had to get lazy loaded. And you can store this information inside of a configuration file. In this case, it's Vite. And it looks basically something like this. Normally, you wouldn't write this by itself, but basically we're saying all these symbols, I want them to be together inside of the Algolia bundle. And one of the things I'm going to do is I'm going to now include the bundle here. Now, this is a manual way of doing this right now, but we're working on a system that will automatically observe what the users are doing and produce these configuration files automatically for you, so you don't have to do that. Let me just rebuild and restart it. And the thing I'm going to show you, oops, if I refresh the page, sorry, it's still rebuilding. What I'm going to show you is the number of chunks has been greatly decreased. So now if I go and navigate to the network tab, again, nothing in here. If I go and find our search button right here, the number of chunks has been greatly decreased, right? Because we were able to put many related things together into the same bundle. And so the idea is that when you build this application, originally you don't have the best possible bundling system. There's some heuristics we can produce, but for the most part, you don't have the best possible answer, right? But you're never any worse than just downloading the whole application in the existing systems. As the users actually use the application, you can collect information about which symbols are needed when and which symbols are always needed together. And then that information can be fed back to the build system, to the configuration file, to make sure that the new iteration of your system will have everything loaded in the best possible way. And of course, you can configure the service worker to just download the whole application, and all of a sudden you have offline mode for free. Right? So you have many, many different choices, and these choices are not a responsibility of the developer to design their application a specific way. Rather, it's just a configuration information that you have to tell Qwik on how exactly do you want to run. Right? Just as we told the service worker, the default behavior is for the service worker to only download the things that are reachable, you could have a different strategy that does different things and make it available offline. Now, the other thing that the service worker does is that when you're in this state, the only thing you can possibly do is click on the search button. So the service worker goes and prefetches the search button. But if you're in this state, there's new interactions that you can do from here. And now the service worker is a step ahead of you and says, you have transitioned to a different place. I now see more things that the user can interact with. Let me go start prefetching those. And so the service worker is always one step ahead of you. So that you, as a user, you will never get in a situation where you click on something and you have to wait for network. Okay, let me switch gears a little bit and talk about personalization. So one of the cool things that we can do is we're working with Cloudflare on this idea of multiple edge workers collaborating to produce a single HTML output. So in this particular case, what we have here is a page, and let me make the font bigger. And this page is made intentionally slow, so you can see how the individual items are streaming very slowly. But what's interesting is that every single box you see, this box over here and this box down here and overall, is a separate container. You see these containers here? That's one container, another container. I'm sure there's a footer somewhere and there's more containers. And so this particular page, I think, is 4 different containers. In other words, 4 different service workers collaborating together to produce a single output. Now, what I find fascinating about this particular page is if I refresh, as the page is downloaded, I can start interacting with the application. And this isn't the case with normal systems, because normal systems require that hydration runs before you can interact with the page. And the hydration cannot run until streaming is finished, right? So normal systems have to finish downloading the whole HTML, then they can start downloading JavaScript and executing the hydration. The hydration cannot happen until the page is finished, which means the page isn't interactive until the hydration happens, which means what I just showed you is pretty hard to do with existing systems. Now, the reason why this matters is that we're working on a new demo, so I'm trying to build this particular demo. This is not working fully yet, so you have to kind of indulge me with the imagination. But the thing we're after is personalization, right? This is basically a standard e-commerce website with a menu on the top, some hero image on the in the middle, which you can interact with, something that's trying to be sold to you, and finally a set of comments or reviews on the bottom of the page, right? And what we're trying to do is make personalization. So what's missing out of here is your name and the shopping cart, which is going to be added later. And what I want to have is basically a page that says, like, you navigate and I say, oh, you like 3D printing. Let me show you a hero image about 3D printers. Somebody else comes in and the system is like, oh, you like rock climbing equipment. Let me show you rock climbing content, and so on and so forth, right? Now, the reason why this matters is because the overall page cannot be cached, right? It's specific to every single visitor. Every single visitor essentially gets, ideally, a different page, because every single visitor is a different person with different preferences and so on and so forth. And so you can't cache those pages. In other words, you have to server-side render every single request. The problem with existing systems is that's expensive. And so a lot of people don't do it because it's just too expensive. that the way Qwik gets around this problem is it says, you know what? I understand this concept of containers, and I know how to mix and match different containers together. And so the menu system goes and gets rendered by a separate worker. Except that worker says, you know what? Everybody has the same exact menu system. There's nothing for me to do. Let me just return a CDN cache from the cache and basically says, this is your menu system, right? Now, the next part over here that's missing is the shopping cart. There we have no choice. We have to go and render the shopping cart. The next bit is showing you the hero image. And again, the same thing happens. Every single person gets a different hero image, but there is a finite number of hero images, so a sub-worker can say, oh, I don't have to render for you specifically. I can just go in the cache of all the possible hero images that I have, even if it's 1,000 of them, and I can just return from the cache the thing that you want, either a 3D printer hero image, or rock climbing 3D image, or shoes, or clothes, or whatever is it that we think you're interested in. And the final bit is the reviews. What if the reviews didn't even show up because they're below the fold? What if they only showed up when you scrolled? Just like the clock situation where nothing happened until the clock comes into the view, wouldn't it be nice if you simply ignore that whole problem and not even send it and just start scrolling, and it's when you start scrolling we go and fetch the reviews and put it inside of it. And so we think we can get personalization, we can get ideal personalization for everybody using this particular strategy of breaking the problem down into smaller workers and then have multiple workers collaborate on the response and produce this. And what makes Qwik unique in this way is that we understand this idea of containers. Where are they? Right here. And these containers allow us to have multiple applications that are rendered by different systems, that have different chunks to download, that have different service workers that have to make sure that the buttons, the source code is preloaded, and all of this can work together in a cohesive system. Which again, as I'm going to say, it's very different how existing systems work. Like in theory, all of these things that I'm showing is possible to do with other systems. In theory, that's a stretch. The thing is with Qwik, that's just how it works. There is no other way of doing it. Okay, so we did a bunch of demos, and I have a few more slides that I want to go through, but hopefully you found this interesting. So in databases, there is this thing called the Cap Theorem. And a Cap Theorem basically says, databases have this thing called consistency, availability, and partition tolerance. You can have any two of these features, but you can never have three. Right? I'm sure you guys are familiar with that particular thing. Turns out, Google broke the Cap Theorem. They had multiple data centers, and in each data center, they placed an atomic clock, and that's how they synchronized the time. And as a result, they were able to actually build a database called Spanner that actually has all three of these things. So they kind of broke the Cap Theorem. And so we're saying, hey, it's partly as a joke, partly serious, there is this idea of a front-end Cap Theorem. And in our case, what we're talking about is there's a lot of different frameworks out there. And some frameworks are really good at capabilities, like React, Angular, Vue, Svelte, etc. Wiz is one of them, like Svelte. This is internal framework at Google. Other frameworks are really good at developer experience. Again, React, Svelte, Qwik. Maybe not Wiz, because Wiz is kind of hard to use. Other frameworks are really good on startup performance, like Astro. But if you're using, for example, Astro, you have an amazing startup performance, but you don't have all the capabilities. There are certain things you just cannot build with Astro. If you choose React, Angular, or Svelte, your capabilities are awesome, your developer experience is awesome, startup performance not so good. And so we're living in this world where no matter which framework you choose, you're always only getting 2 out of the 3 things. And the thing we want to do with Qwik is actually break this and actually say, no, I want to have a framework that can deliver all 3 of these things. I want you to have an amazing developer experience, so as a developer, you don't have to think about any of these things. I want you to have no limit, and you should be able to build anything you can build in today's technologies or frameworks. And at the same time, I want to have an amazing startup performance. And so I want to have a framework where all of these 3 things are possible. All right, so that was my presentation. A little bit about Builder, so this is kind of the stuff that we're working on. So Builder is a visual CMS system. And we have a lot of e-commerce customers, not just e-commerce, but other ones as well. And this is why we're working on Qwik, because Qwik is the thing that enables our customers to have unbelievably fast websites, right? And at some point, when you start building websites, you're going to say like, I need a content management system, I need A/B testing, I need personalization, I need all of these different things. And if you use existing systems, you run into limits of what you can do. And so this is where Qwik comes in. But turns out, the first-party code is only part of the problem. The second part of the problem is a third-party code. And third-party code being like analytics, Google Tag Manager, HubSpot, and so on. And so for that, we have Partytown. Partytown I haven't talked about much, but it's an interesting piece of technology that takes third-party code and moves it to the web worker. Notice it's the same strategy, right? Like we want the main thread to do as little work as possible because the main thread should be reserved for the developer, for the user, right? And so both Qwik try to figure out how to offload as much work from the main thread as possible, and Partytown tries to offload the third-party scripts into the web workers. And finally, we have this technology called mitosis. What mitosis allows us to do is to write code once and then generate the canonical code for any existing framework. So when we, for example, build our SDK that allows you to connect Builder.io to existing frameworks, using mitosis, we write the code once, and we generate code for Angular, Vue, Svelte, Qwik, and whatever other technology, web components that you want. So anyways, that's what Builder does. So thank you very much. I am going to be hanging out outside, so come and talk to me. I have some swag to give out. Happy to answer questions. I guess we have 3 minutes. Can we ask questions? Is that how it works? Okay, we have 3 minutes so we can talk about stuff here. Afterwards, I'm outside and I can answer more questions. Questions? So the question is it possible to have just parts of the page in Qwik? Yes, it is possible, but you're not going to get all of the benefits, right? Like the idea behind Qwik is that you want to offload JavaScript off. So let's say you have a mixture of React and Qwik. And oh, by the way, I forgot to mention, totally slipped my mind, I have actually a demo of where you can use existing React components inside of Qwik, and they get hydrated when they become visible. Basically, you kind of get Astro for free inside of Qwik. You can mix and match these technologies, right? But the problem becomes that the moment you have a framework that eagerly hydrates, you are paying the price and your application is now slower. Now, it's still a better solution than what you had before because instead of hydrating the whole page, you're hydrating a smaller chunk. So certainly it's an improvement, but you're not going to get amazing scores until the whole page is quick. Yes? Right, so the question is, what happens to Qwik if other frameworks say, hey, this is a good idea, we should all do this? I am skeptical that it is possible to take existing framework and add resumability to it. The reason I'm skeptical on this is because, well, I worked hard on Angular, and so I have some ideas of what it takes. The second thing is, the problem with resumability, or rather the thing that makes it difficult, is that you have to be able to serialize your whole application into HTML, not the whole application, just the state, right? And you have to be able to download the JavaScript code lazily. And the requirement there is that you need to, because it's lazy, it has to be asynchronous. And so you need to have a rendering pipeline that's asynchronous that can do all of these tricks. And the problem is that if existing frameworks try to implement it, they would essentially completely break the compatibility with existing ecosystem that they have, right? None of this stuff is secret. Anybody can see how this works because it's open source. But the problem is, if you implement it, you will find yourself in a situation where your existing ecosystem becomes incompatible. And so I'm going to go on a limb and say, I don't think any existing framework will go out and say, let's break and make all of the existing ecosystem incompatible with us just so we can get resumability. And so this is why I don't think this is going to happen. So it's a hard, tall order. You cannot add resumability and still be compatible in the way you work. When you add resumability in, there are certain constraints and certain way of like dealing with the problems that is different than how existing systems work. And because of that, I don't think it's as easy as just adding it in, and I don't think it's going to happen. Yes. Is Qwik being used in production? Yes, so our homepage is in production. There are maybe 24 of other websites that I know of that are being in production. A lot of people are trying it out and etc. It's certainly at the beginning stage. We have just announced beta about a month ago. So, things are still happening. But yes, already people are using it in production. And basically what they're seeing is like, oh my gosh, I didn't have to do anything and I'm having amazing page speed scores. Yeah, the end goal is that we want to make sure that Builder.io customers can use Qwik, because a lot of Builder.io customers are customers that deal with conversion problem, right? Either landing pages, or they're trying to sell something or collect information or signups or page views or anything you talk about. And all of them have the same problem, which is that performance of these websites is not fast enough. And oh boy, if they can only figure out how to make it faster, their business would grow so much more. And because that aligns exactly with what the Builder customers are, this is why Builder is investing in Qwik. Yes?
What about the developer experience, about things like forms,
Routing, okay. So what about developer experience and routing, etc.? We haven't really talked much about developer experience, but it's essentially the same as what you're used to from other frameworks. From all of the possible frameworks, I think Qwik is kind of like a halfway point between between React and Solid.js, if you're familiar with those frameworks. You have JSX. We have Qwik City, which is equivalent to Next.js, or Solid Start, or Nuxt, or Angular Universal, which is the file-based routing system. The file-based routing system starts as a multi-page application, but the unique thing about Qwik is, because we can lazy load all these things, is we can transition from APA to SPA on the client without basically the developer having to do anything. They just instead of href, they have to put a link in there. So all of the basic things that you think of to build a site, whether it's delivering, authentication, etc., is covered either by Qwik itself or Qwik City, which is kind of the add-on meta framework for Qwik. Yes?
Two things. You said that you try to learn which JavaScript will be pushed to the client. Is this not exactly the thing that HTTP 3 failed and removed from the protocol, that why nobody was using it?
Okay.
Yeah. And the second question is...
I'm going to forget the first one. Okay, let's go talk about the first one and then do this. Okay, so the question was, our observation of how do we know which symbols are used when, and isn't that the same thing as this protocol that we have? And I can't remember the name. At some point, I think it was HTTP 2 or 3, there was some protocol that knew how to do these strings. Yeah, it's different, mainly because the underlying protocol didn't understand the application, right? And so as a result, there was very limited things that it can do. What's unique about Qwik is that Qwik, most frameworks are like, oh, I just do rendering, and I don't care about bundling or serialization or anything else, right? Qwik actually looks at it holistically and says, no. Of course we do rendering, but we also want to do server-side rendering. We also want to do serialization. We also want to do bundling, figuring out prefetching. Basically, Qwik says the whole problem of building an app is our problem for the Qwik, right? And because Qwik owns the whole thing, an interesting thing arises is that the Qwik runtime actually understands the bundles and understands the relationship between bundles. And because the Qwik runtime understands this, it can do all kinds of tricks that the underlying HTTP protocol couldn't do, because it simply didn't have visibility. So for example, the way the service worker works is that it tries to prefetch the files, right? When you scroll a page and a particular link comes into the view, the service worker increases the priority of that prefetching. Says, this thing is now more likely to be clicked because it's visible, and so I'm going to start downloading this first. The other thing it can do is that when you click on something and you transition to a different page, right? Now the service worker says like, oh, now I see a completely different set of links that you could possibly interact. Let me start downloading those and prioritize those. And of course, it can also just say like, hey, you know, I see a link, but I also understand that if you click on this link, you will cause a waterfall to download these other things as well. And so I understand the relationships, and I can kick off the fetching of the waterfall as well ahead of time before you even come in. So basically, it comes down to visibility and having the right kind of information. And Qwik has that information and provides that information to the service worker, whereas the underlying HTTP protocol that you're referring to, which I can't remember the name, did not have that information, and so it was very limited in what it can do. Now, I had a second question.
Thank you. The second question.
Are we going to kicked out? Yeah. We're getting kicked out. Okay. So, okay.
The server side, you never don't talk about the server side. What is on the server side? Especially if you have a Java service having the personalization.
Okay. So we have to go in. I am going to be outside of the door, and I'm happy to answer any question you want. I'm happy to give you a whole bunch of swag, which I don't want to carry with me, so please help me get rid of it, and I will answer your question.